In June of 2015, Google published a blog post about Inceptionism, a neural net that hallucinates. The idea behind the project was to showcase the features learned by different levels of a convolutional neural network. This was done by applying the learned features onto different images, which yielded results that were interesting and sometimes a little amusing. Jason Toy of Somatic has implemented Inceptionism in their model marketplace. As we've seen in episodes 3 and 8, a convolutional neural network learns progressively complex features by assembling simpler ones. In the example of face detection, it first learns features like edges and color contrasts. These simple features form more complex facial features like the eyes and nose, which are then combined to form the face. The neural network does all of this on its own during the training process without any direction from the person building it. Neural nets are almost always built with a specific task in mind, but as we saw in episode 27, it's extremely helpful to reuse what a neural network has already learned. By letting the net learn on its own, the builder surrenders control over what each individual layer does and learns. This is an important benefit for something like facial recognition, since there are so many different ways that a set of pixels could form a facial feature. But as a downside, it's not always clear up front which filter or layer will learn which features, and at what level. The Inceptionism project is an effort by Google to figure out what a given layer learns, and reapply that onto other images. Up to this point, we've seen how a deep net can discriminate between inputs and assign them to a class or set of classes. In image recognition, for example, a deep net can analyze a digital image and label it as a cat picture. However, deep nets can also be used in generation. Given an output, they can generate a set of corresponding input data that would have resulted in that output. So as an example, think of a cat detector model, which would need to produce the original cat image. Working in reverse, the model would start with the cat, then break it down into features like the face and legs, then further down into edges and color contrasts, and then finally into the pixels that make up the digital image. The key insight from this project is that the learned weights and biases of the discriminative CNN model can also be used in generation. By extracting the learned features from a network and applying them to a random image, those particular features of the image are enhanced. So if you extracted the features from the edge-detecting layer of a model trained on animals and applied it to a natural scene, any edges in the scene that resembled those found in animals would be enhanced. On the other hand, if you applied higher-level features like a dog face onto a nebula image, you'd end up with a strange-looking combination of the two. It's important to understand that this is not just superimposition. The model is gradually tweaking the features in the image to look more and more like what it learned from the original network. This actually results in an intertwining of the two. Here is Jason Toy to demo Inceptionism.
So now I'm going to show you the Inception model running on the Somatic platform. First, we're going to upload a picture, my profile. Then we're going to show what it looks like going through the different layers of the Inception model. Now remember, the model is automatically learning features from the images it was trained on. So if you're training a classifier, in this case, it's going to learn the features on a low level, and then as the layers move up, it learns higher and higher levels of abstraction. So here's a lower layer where it has started to learn things like lines and edges, and so you see these lines and edges exaggerated in the image. Now we'll process it again, a few layers up, and you can see that it's starting to see shapes, such as it looks like eyes and other circular objects, and it embeds that back into the image. Then we're going to look up a layer higher up, and we start to see looks like faces, shapes of animals. You can see the eyes, noses, other features of animals. And then a layer even higher up, you see it's a little bit more abstract, but you can see multiple different types of animals, it looks like, and eyes in the picture. So this was just a way to visualize back onto the image what the neural network has learned and is seeing in the image itself. So that's why they call it Inception. It's recursively looking at the model. So you can also build, that means any type of model you'd like, using any type of training data. So the model that most people see is trained off of ImageNet, which has 1,000 classes, but you could train it on your own images of other things, and then your model would learn those visual features in the image.
Even though this project has no immediate application, it showcases the concept of generation, which is an essential component of knowledge transfer. If you want to learn more about deep learning, hang around after this for our recommendations, or visit us on Facebook and Twitter. Thanks for watching, and we'll see you next time!